Hello, everyone. As was just said, I'm Ron Bakker. I'm a partner at PLP Architecture. I'm going to show you lots of pictures because pictures are our work. And there's a couple of films as well with loud music and flashing lights, so don't be scared. The project I'm going to talk about is now called The Edge. I've been working on it for a very long time. It survived as a project, a bad recession in the Netherlands, which is not quite over yet. And it gave us time to consider a bit more than is normally the case with speculative office buildings, what this building should be like. But watch this little film. Okay, PLP Architecture. We are a young firm, but we've been together as a group of people for 22, 23 years. We used to run the London office of Cohn Pedersen Fox, and you may have heard of us some 15 years ago when we did some projects in Prague. And a little bit of an indication, our work is very broad. We do a lot of residential, university buildings, we do tall buildings, we do small buildings, we do pretty much everything and anywhere people will have us. But we've always been very focused on Europe and Western Europe as a market, coming from an American tradition. My partners are Americans. We have been looking at sustainability as part of the design process for a long time now. A lot of architects will say that, and especially these days, but we completed this building in The Hague in 1997, and it was a project that extended existing provincial headquarters buildings, and there was a whole story about its orientation, the way it dealt with the noise from the motorway running around, how it dealt with the sun shining into the building and into the plaza. It had a cold and heat storage system in the groundwater. It used its public spaces to ventilate the project. It was 20, what's it? That's, yeah, it's almost 20 years ago. And it was quoted at the time, and I've never been able to check, in some Japanese magazine that it was the world's most energy efficient office building. I don't think it's true, but it was nice to be heard. The building, I go there sometimes, still functions really well. It's a wonderful place. The Heron Tower is quite a famous building we did in London, which is a tall building, but it's the first tall building in London that uses the orientation carefully to preserve energy and to allow daylight into the building. It's actually the diagram that makes the building. So we'll see quite a lot of that. Unilever's headquarters, a building which was very dark. On the left, the before situation, a refurbishment of a building from the 1930s. Small light wells, quite a tall building, a very dark office space, which we kind of ripped out all the back and made one bright atrium in the middle of the building that provides daylight to all the workspace. And this one you might recall, Danube House on the river, which was a building that's totally about orientation, with its north face on the river, where the sun does not shine and the trees cool the space. It's clean air, and a protective atrium to the south, protecting against the sunlight and the noise from the road going past. But actually, that diagram made the building. The atrium is part of the air circulation through the building. The cool air from the river bank is sucked by the thermal rise of the air in the atrium through a labyrinth of channels under the car park to be pre-cooled in summer and preheated in winter, all free. We haven't spent a penny on electricity yet, and the office space is already partly ventilated. I think it's a wonderful building as well for the city, and I love the space from the inside. It's a place where people gather, and from what I hear, people love to work there. So this is also quite some time ago, but when we started looking at the project in Amsterdam, Deloitte was a tenant to the building at the time, and they put out a question to the market: who's going to develop our headquarters in Amsterdam? They have about 40 office buildings in the Netherlands. And they wanted to consolidate 3 or 4 in the Amsterdam region into one building. OVG Real Estate, a young and dynamic and ambitious small operation at the time, won the competition with my help, I must say, to provide this building for Deloitte. And it's placed in the CBD, the business district of Amsterdam, which has been growing for the last 20 years. It's about 5 minutes on the train from Schiphol Airport. It is 10 minutes on the underground to the city center. It's possibly the best connected business district in Europe. The fast train will stop right there at the station that would be the Amsterdam station when it finally arrives from Paris and takes you through to Hamburg. The location could not be better. Deloitte had recently completed some projects. Their headquarters in Rotterdam is a tower on the river, wonderful building, great views, but people don't feel they're part of the building. They told me recently, I work in the Amsterdam office and in the Rotterdam office, and I really miss the idea that you have one big space in the building, which is the whole idea of their project in Amsterdam. Similarly, in The Hague, a very well accessed location, but a standard office building. You get into the lift, you go to your floor, the 7th floor, you walk to the left, there's your office, and you say hi to the people you know, but you know only about 12 people. So the idea in Amsterdam was to create an atrium. This was the competition design, already some 7 years old. It had an atrium which had the circulation in. It also had a little mast calling for attention. It's possibly one of Amsterdam's best locations at the moment. Very visible. But what Deloitte really felt like creating, and that was our first discussion actually during the competition, was to make a place where people who worked in the building felt they were part of it. And they could talk to people that they didn't necessarily know, even people from other companies. They really wanted to create a community, and they wanted to share knowledge. We'll be talking about that a little bit more. There was no word about sustainability at the time. The Netherlands had quite strict building regulations for the use of energy and for the use of materials when we started a project in 2007, 2008. But there was no accreditation system like we have now. The building sits along the motorway. It has a north-facing atrium. It's lucky actually in its location, because on the south side it will eventually be part of a new block structure of buildings which the city is developing in the area. Some of these buildings are existing, most of them are not. On the north side there is a 150-meter wide infrastructure bundle with trains, underground trams, the motorway, and it's actually a dike. And if you've ever been to the Netherlands, or even if you haven't, you know that most of it's underwater. And if it wasn't for the dikes, we'd all be better swimmers than we already are. And The idea of a dike is that, you know, you pump the water to a higher level and you keep pumping it over the dikes until you can ditch it into the sea. And it's what the Dutch have been doing for 800 years. And people say sometimes that's why they are so good at getting together, put their heads together, make a decision over something that needs to happen in the next 20, 30, 40, 50 years. And they do it. And it's because they've been protecting against the sea. Now, one of the typical Dutch buildings that came out of this dike phenomenon is called the dike house, would you believe it? And it's built into the dike. The family lives on top of the dike. The road is always on the top of the dike, because otherwise you have to go under and you have to go over. It's better to stay on top of the dike. So the family enters the house, and the kitchen and the living room is on the top of the dike, whereas on the bottom right, the stables and the farming equipment is where the farmland is. Very nice. You always look over the dike, and the building, this is a section through it, has the same aspect. So it has the public space in the atrium climbing up to a level that gives you a view over the dike. One of the principles of this, of the design of this project. But really, the orientation of the building has to do with the fact Deloitte wanted to be on the motorway, show people where they were. They wanted people to look into the building, as well as people looking out of the building to the great view. So the orientation then, this is really the most important picture of this whole presentation, because energy in modern office buildings is about the battle between sunlight and daylight, okay? Daylight's good, sunlight's nice, but not so good. It warms up your building. You have to cool the hell out of it for 6 months a year if you let the sun shine in, but you do need the daylight. So there is some noise and pollution on the north that made the atrium a good idea as a buffer. The daylight is free on the north because you don't have to filter the sun away, so you want to let it in as much as you can. During the day you have to shade in the east, south and west facades, so you don't let too much solar gain in. The southern sun is the hottest and the most energetic, so you should open the building to the north, and you should close it somewhat more to the south. You can provide more structure there to have thermal mass to soak up the energy in the morning when the building is nice and cool. The first couple of hours you don't need to worry about cooling because the concrete will soak it up. You have to provide shading but allow the daylight in, so don't close the top of the window, close the bottom. And you can provide photovoltaics on the south facade where the energy is high. So to prove that, and we worked parametrically a little bit. That's a whole different story, but it's nice to be able to use the technology we have these days to work out what is actually really good. And Chris talked a little bit about metrics. I don't know very many numbers, but the theory is all there. So what we did is compare the amount of daylight coming into different floor plates. And if you take our 2,500 square meter floor plate on the left and you don't have an atrium, that wouldn't be allowed in Holland. Everyone has the right to sit by a window. If you open it up and make an atrium, you can see the dark blue is disappearing already. That's the darkest space. And if you open the shape of the atrium a bit more, you get a lot more daylight in from the north. And in the last picture, we shaved off a pyramidical piece of the massing of the building to allow even more daylight in. And we've now found ourselves with a situation where we only really have dark purple where we have cores in the building. So the floor plate design is based entirely on daylighting. Apart from other things, there's functionalities. We have 2 cores in the atrium. The building can be divided into 3 tenancies per floor if necessary. And the engineers told us exactly how much glass we were allowed to have in the different orientations of the building. So in the north, as much as possible. The 70% actually is full height glass. The spandrels where the floor is closed, but the rest is all open. And when we go around the building, the facade changes according to the orientation, so that in the atrium we have totally clear glass. It's double glazed to preserve some heat, but it is allowing every bit of daylight in. On the north-facing facades and the atrium facades, we have 100% glass, and then we start to close it off with quite deep elements that provide some shading when the sun is at an obtuse angle. And on the south, where we have that powerful sunlight at, we think at noon, but in fact it's for quite a long time during the day. We collect solar energy on the solid panels. So these panels come in all sorts of colors, as long as it's blue. And we kept our fingers crossed that it was going to look beautiful, and we were lucky there. That's the only material we didn't really pick ourselves. The roof is covered with photovoltaic cells, and this little film shows you what the sun does to the building at different times. So the sun goes up at, this is around about this time of the year, and you can see at about 8:30, the sun is already shining on the southern facade. So you think it's a noon sun, but in fact the solar panels are already collecting the energy. Then there's an optimum angle for the roof. The roof level is pitched by about 7 degrees to maximize in Holland the solar exposure of the PV panels. Solar noon, because of the daylight saving hours, is a little bit later than noontime, but this is what the sun sees when it's most efficient, so it's almost all PV cells. And then the working day is almost over, and the sun is still shining on the south facade. Every time it does, we collect energy. Not enough, because to become truly carbon neutral, we had to rent roofs of other buildings to put solar panels on, which we did. And we totaled 4,200 square meters, I think, of solar panels. Now, this is all very fast because there's a lot to say. The building uses the aquifer at 130 meters deep to keep the summer heat, basically, and use it in the winter, and to keep the coolth of the winter and use it in the summer, balancing over the seasons the water temperature that's used for all of the heating and cooling in the building. So all you need to do is pump it up. And the structure of the building, and this is an important sustainability issue. We talk about energy a lot, but in fact, you have to make these buildings as flexible as you can, and the elements that are going to last our lifetime should really be used for other things too. So we don't probably need office buildings as much as we do now in about 50 years' time, but the structure of the building can be used as an academic floor plate or even as residential, and we had to prove that to the city of Amsterdam. So it's prefabricated construction. Every piece of concrete in the building besides the basement is prefabricated, lifted onto site by about 3 guys working on site. It's unbelievable. They put the whole building up like a house of cards. And it's all very efficiently constructed. Deloitte is the main tenant of the building. They take about 7 floors out of 13. In the project. They have become increasingly involved in the quality aspects of the building as the building was being developed and designed. And they've become a real partner in attaining these incredible sustainability levels that the building eventually got. And the reason for that is that both OVG, the client OVG, is mad about sustainability. They saw the advantages commercially of doing this. At a very early stage, they made a promise to Bill Clinton. They spoke to Al Gore, and you don't really need the Americans to tell you that the world is going into the wrong direction, but they do go around and talk to people. And they pledged to invest heavily in sustainability. Now, the building eventually got a BREEAM rating of 98.34%. I haven't quite worked out whether we could have actually get the 100%, but it means we have done everything physically possible. And there's lists of hundreds of things to do. And the last few points we got from the solar panels on the roofs of other buildings. But in the process, there are 21 innovation credits. It stops nowhere. The investment is quite big to do this. And the question that you're going to ask me if I don't tell you the answer now is how can you afford to do these things? Well, Deloitte, our accountants, they've worked out their investment comes back in 10 years' time. It's not a problem. The building was sold to DECA, a German open-ended fund, who came to see the building and heard about the sustainability credentials and said, this is a dream come true, how much? And they paid really handsomely for the project because people don't buy buildings that are not sustainable. Okay? This is a change that happened in the last 10 years, and it's an important one because it means we can now consider investing into these buildings. There's a bunch of other things happening, and Erik is going to talk about the sustainability, but for me, the most important aspect of this building is that the people love to come here to work. There are 2,000 people working for Deloitte. They have 1,000 workspaces. Okay, they don't have their own desk. Nobody has their own desk. They come in the morning, and I think there's a little film about the happy people coming in to work in the morning that I'm going to play quickly before my time runs out. So 11 o'clock, because then the lights go out, because otherwise you don't get that BREEAM credit for electricity use at night. Okay. So in this building, everything is totally connected. The fellow comes into from a meeting at 11 o'clock. The car park knows that it's his car. They read the number plate. The arm barrier goes up automatically. His smartphone tells him where his desk is. He has to choose. Do you want to sit with your work group? Do you want to sit with people you don't know? Do you want anybody to know that you're there? You can say no. And when you get to your workplace, the temperature will have adjusted to what you like. Each of the workspaces the temperature can be lowered or made higher by 2 degrees. So there's a range of 4 degrees. The lighting levels are set at 350 lux. If you want more, you can go up to 1,000. You can do this all through your smartphone. Everything is connected. The building knows everything about everybody. Now, this is a big issue because we can learn from this. And Erik will tell you about this a bit more. We can learn exactly how the building is used. For the first time, we can measure energy use every minute of the day. It's wonderful. Everything is connected. Each of the light fixtures has a little IP address. Okay, it's powered through the Ethernet, which means the light fixtures can talk back to the building. And every light fixture measures various things that Erik will talk to you about, and it collects vast amounts of data. So the huge interest of people like Microsoft, who've just bought Nest.com for $6 billion, not because it's so nice to be able to switch your temperature off at home when you're in the pub, but it collects data. And data are a valuable asset these days. In the new kind of functioning of life, this building is very, very interesting. Deloitte have caught on to that. They are organizing their staff, transition into the digital world. They're seeing how their company can evolve to go into the digital world, and this building is part of it. Thank you.
Okay, thank you very much for inviting me to telling you something about the technology used in the building, which was a big contribution by a lot of firms, not only by Schneider Electric. Of course, I would be pleased if it was only Schneider Electric, but it wouldn't be fair to state that it was only our accomplishment. I think maybe the biggest innovation was that we came at a very early stage involved with OVG and with the specifier to design a setup of innovations and solutions to make it able to behave the building like it should be as designed by Ron Bakker and his team. And we had to design some special solutions around energy management and energy capturing systems to let it behave and contribute to the system as designed before. So I think that's something which is maybe forgot too much, that in the end it has to be done by people. And people work at different companies, and there is a lot of knowledge outside. And the real question is to bring those knowledge on the table and to merge it and to find better solutions together, because I feel a bit humbled to stand here while it were not only my ideas, it were ideas from great engineers from several companies, and we created the environment to let them share and to let them contribute and to come up with solutions we would help creating a difference. So it were quite open discussions around, for instance, budget, what Ron was mentioning. It was not a cheap building. And I have to say, 5-6 years before we would deliver, there was a room to discuss, to invest in systems who would contribute in the benefit of energy usage or in sustainability. So it was not only about the dirty deal of money, it was about sharing knowledge and creating an environment to also participate in better systems, and they could be financed within the systems. The big thing was data. It was the problem, sorry, not the problem, what we try to obtain, that's what all the data gathered out of the various systems should contribute in a better system, and systems could learn from each other. So what we tried to create was an interoperability between those systems, gathering data, and to make the data available for the various systems. So it would not be the data from The Edge or from Schneider Electric or from Philips or from whoever was involved. It should be data where we could take the benefit of to optimize our systems as we would design afterwards. So, and we really believe that if you look to smart grids, and smart grids are starting to enter more and more within inside the building, that the grids should be smart and should be connected to the IP where we will come on to further on. So, as mentioned by Ron already, of course, the power over Ethernet Lightning brought a big contribution on energy saving, which is truly there. And the most important thing was that it generated a platform, a backbone on IP, where we could leverage on with all connected systems. So we created a universal backbone built on IP to connect with lighting, the ventilation systems, the access control, etc., etc. What we did about the CO2, in meeting rooms, we measure the CO2 and we steer the amount of air inside the rooms based on temperature, number of people available in the room, and of course the temperature. Climate ceilings were used to climatize the air, and the air was, as was shown in the film of Ron, pushed out to the atrium, then going up to the air in the atrium, and reused there the energy to go back directly in the HAU units. So thermal storage was the biggest part of the energy consumption for heat and cold water, and district heating was used as a backup. The colleagues from Daikin, I don't know where they were asking her what kind of chillers were they used. I have to be honest, I don't know. But because the majority of it was produced by the thermal storage, and I'm sure there is a chiller, but I don't know for sure which one it was, how energy it was. So sorry, I will let you know afterwards. Maybe it was yours. I can't tell you. Integrated technologies. Just to name a few, as Ron was describing, each floor has 3 sections, and each section has provided with its own electricity, its own heat water, its own chilled water, and it's all been measured on that level. So each floor it has a lot of energy meters to at least measure and create data to analyze afterwards and to tell something about the sustainability of the building and the behavior of the people within it. Because no one has fixed desks, they move around. And if you have the data about how many people resided on that floor that day, and you have the energy consumed in that floor, you can analyze that and start analyzing why floor 3 uses more energy than floor 4, and you can start taking actions to provide or create that it will operate exactly the same as projected. Interaction with apps, I will show you a bit further on. And what we did with our systems, and I'm proud that except for the lighting, all the equipment, we were able to participate and to deliver there, is of course we want to reduce energy, costs and wastes within it, and it starts or ends, this is how we want to call it, with measuring and with analyzing, because of course you can make very energy efficient lighting, but if you don't measure afterwards, how on earth you can know if it was really energy efficient? Or if you plan to stop burning the lights at 11 to get the BREEAM credit, but you don't analyze that it's really been done, there will not be a saving. So energy measurement and analyzing is a critical part to let it really behave as a very energy efficient system. Data is maybe the big next thing, as IT companies would say, and I think that something definitely is true for buildings. We used to use a lot of data from our customers who analyze their behavior and to use it for our businesses. But data becomes more and more a part also from our building technologies, our building management systems, to start also leveraging on it in the building itself. What I said, we basically created the total technical environment from plan to plug. So that means that right from the trafo, from the mid-voltage part until the very last plug, we designed an architect with bus bars, substations, meterings, power factor controls, power factor correction installations to create a very energy efficient and very trustworthy installation. Now, as Ron was mentioning already, a lot of solar panels are connected to the building and or the surrounding buildings. And of course, if you want to prove that you would earn that credit, you have to measure that it also in the end provides the amount of energy as you had projected before. So energy management, again, was a critical part in it. One of the things, I don't know if it's very common to use in Czech Republic, but the reuse of rainwater, as it is in the Mosaic Hotel, but also low water consumption of toilets. So we flush the toilets with a lot of less water than we are used to. And not in this building, but in our own building, we even use urinoirs. We doesn't use water to flush, so it's on water you can save a tremendous amount of water, and thereby also the energy needed to create clean water, because we flush toilets with clean water, which you can drink, which is, if you think about it, it's quite a silly thing, because why use clean drinking water to use flush toilets? So the reuse of rainwater really makes sense, and it's very far from what I'm doing in a day-to-day job on automation, but I think this is also one of the things within sustainability and where BREEAM and LEED kind of credits really makes sense to use and to benefit for architects and investors to create very healthy environments and sustainable buildings. Ron was mentioning that in the Netherlands our regulation is already quite tight. Although it's quite tight, we saved 48% of CO2 emission on the building. 48% on a building in an environment where we already have a tight regulation. So I think that indicates that the installations and the design of the project really made a big difference. And a lot of technologies and overseas, as Ron was saying, he was doing it 20 years ago, were there already. And if you look to the innovations, also within the building, they are there, no doubt about it. 21 innovation credits were delivered. But if you look into it, a lot of those things we knew yesterday, and we know tomorrow, and I think we start using this much more often to create much more buildings and to beat this kind of buildings, let's say, every day. So in 20 years, we have much more sustainable buildings, because it really can be done. The energy efficiency is, of course, also about consuming green, there is nothing wrong with consuming energy. There is something wrong with how you produce the energy and how you get there. So on-site production, renewable energies are a critical part to leverage on. So something about the background for maybe a bit more technical guys used to work with building management systems. Let's be fair. Sustainable buildings do have a lot of technology. So sustainable buildings are, for technology companies, are interesting buildings because there is a lot of business, you could say. Because you need, if you want to provide all this data and you want to reuse this data, you need technology to gather it, to use it, to analyze it, and to start benefits from it. And there's nothing wrong with it as long as it contributes. If you look to this system, we have a backbone, what I told, on IPv6, and we used 50 automation servers. Maybe not telling everyone what it is. Basically, it's a building management computer. On one such computer, you can run a building like 2,000, 3,000 square meters. So we have quite a heavily dense installation with intelligent components which can interact on floor level. So on each floor level, we have 3 of those devices, and they are gathering the data from the zone controllers, or provide the climate ceiling installations, the lighting systems, the energy management systems, the heat meters. So we provide a lot of data points, something like 20,000 physical IOs, combined with literally thousands, 10,000 virtual data coming from the lighting bulbs, the energy valves, put into place in the building. So we have approximately something like 100,000 hardware or software related I/O points, which we bring into the building management systems, and we use to analyze the system to start optimizing the system behind it. So yeah, all those data became a very big impact. And now, what are you going to do with those data? I always say it's not a problem getting those data, it's a problem what you start doing with all those data. Because data gathering is nice, but if you don't do anything with it in the end, it doesn't make sense. So if you don't think about it, what you will do with it in the end, how on earth you're going to design a system to gather all this data if you can't make chocolate out of it in the end? So you have to overthink in the design process, how do I build up my data gathering system to provide useful data in the end? And I think that's something which is very often forgotten in the beginning. We start plumping in all kinds of systems, and in the end we say, okay, we have a lot of data, what can we make of it? And then we see that we miss vital parts of it. So apps in this case, and MapIQ, which is mentioned there, is not a Schneider Electric thing. It was basically an IT startup from some students who had a great idea how to gather all those data from connected lighting, from the BMS, from all those systems, bring it together in an app for Deloitte. And I have to a bit speed up, I see on time. So it's also providing, just one thing about it, the lights itself know where you are, or can know where you are. So it can help you to bring you to your meeting room. So indoor navigation can be done by BMSs, and is here been done by the app. So if you have a meeting on the 2nd floor in a meeting room where you never have been before, your app can tell you, you take the elevator, you go to the 6th floor, you walk to the left, and your 3rd door at your right side, that's where your meeting is. I think that's a very useful application for building tenants. So in partnerships, same as in Czech Republic, we only work with partners. Partners make our business. So HE Group in this case, my system integrators, played a vital role in it, in creating the system. We designed it, we had a great idea, but they had to do it. Together with Blink Systems, which is the company who built the MapIQ app for Deloitte, they played a key role in making good analyzing data out of all those gathered data out of those various systems. And I think I will skip those because, so I would say let's convert watts into negawatts. And for those who don't know, a negawatt is a watt you didn't use. So it's not about megawatts, it's about negawatts. And if we start thinking about negawatts, then it pushes us in the right direction. Okay.
Thank you, Erik.